Hello and welcome to today's revision session on paper 2 for GCSE Separate Science Physics. So in today's revision session what we're going to be doing is looking at how we can answer examination questions on GCSE Physics paper 2. So if we've been successful and we've learnt in today's lesson, we should be able to answer GCSE Physics examination style questions, assess our understanding on GCSE Physics and understand what topics we need to improve upon for GCSE Physics. So how should you prepare for this revision session? Well, when you're completing your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than the right hand side, and in this left hand side section write down your working out and answers to the questions in the revision session. And then when you're doing this, make sure you're writing full sentences and show your full working out, whilst in the right hand side write down any bits of information which you find useful, any hints and tips on answering questions from this revision session. After the end of the revision session, write up these notes into a revision sheet for you to use independently. So let's have a look at some questions for GCSE Separate Science Physics paper 2. Let's look at the topic of forces. So in 2021, a small battery powered helicopter performed the first ever powered flight on the planet Mars. The mass of the helicopter was 1.8 kilograms. The helicopter took off from the surface of Mars and the helicopter remained stationary above the surface for several seconds. Calculate the upward force on the helicopter when it was stationary. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, first you've got to know that if it is stationary, that the upwards force equals the downward force. And what will the downward force be on any object? It will be weight. So how do you work out weight? Well, weight is going to be mass times by gravity. So we know the mass from the question is 1.8. The gravitational field strength is 3.7 from the question. So our answer is 6.66 newtons. The next question says, Figure 11 shows a person using a resistance band to exercise. The resistance band is made from an elastic material. The greater the force applied to the resistance band, the more the band extends. Plan an investigation to determine if the force applied is directly proportional to the extension for the resistance band, and you should include a diagram. So pause the video now, then unpause the video when you want to go through your answer. Right, when you're answering these types of questions, you've got to be very careful about how you plan your work out, because not half the marks, but some of the marks will come from being able to write in a logical order. So you'll see here for level 3, you need to have a plan which will lead to a valid outcome, but also just as important, all the key steps are identified and logically sequenced. So with your diagram, you'd have a clamp, a boss and a stand, a meter ruler and a band hanging from the clamp. You would use a top pan balance, so you could measure the masses, and then you could have slotted masses, or you could use a Newton meter. So the first thing you'd do is ensure the band being flat. You'd measure the original length of the band with a meter ruler. It's important you always state the measuring devices that you will use. You would then add a known mass, so it could be a slotted mass, you could say 10 grams, 100 grams, a kilogram. You would then also use the top pan balance to measure that mass to make sure it's accurate. You can then work out what the force applied to the band will be by doing your mass times by the gravitational field strength, or you could measure it by using a Newton meter. You can then measure the new length of the band and then calculate the extension. Remember, it's force and extension we're looking at. So extension, which is the going to be the new length minus the original length. You then repeat for more masses. Again, it's always good practice to state what values you will be using, and then you plot a graph of force against extension. And it's important that in a force extension graph, if it's a straight line through the origin, well then it is directly proportional. The object is acting elastically. The next question says that table 2 shows the results. Firstly, explain why the scientists could not use a meter ruler to measure the extension of the wire, and then determine value x in table 2. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this first question? Well, it's important, you can't use a meter ruler to measure the extension of the wire, because if you look at the values of extension, well, you're going to notice that they're given to 0.01 millimeters, because you can see it's given to 2 decimal places in the results table and it's measured in millimeters. It's always important to note what units are being used in tables. So you can see that a meter ruler will only be able to measure to 1 millimeter. It won't have the accuracy to measure to 0.01 millimeter, so it can't be suitable. The next question says determine the value of x. Well, we can work it through because we know that the average value from the question is the mean is 2.95, and you can work out the mean by adding up the three values and dividing by 3. So you'll notice there that you can have x in the equation as shown. You can then rearrange it to find x, and you find x to be equal to 2.97. The next question says, speed affects the braking distance of a car. Give two other factors that affect the braking distance of a car, and then explain how driving at a slower speed decreases the stopping distance of the car. So pause the video now, then unpause the video when you want to go through your answer. Right, so these are just facts. What factors affect the braking distance of a car? Well, it's anything to do with how good the car brakes. So it could be the condition of the tyres, the condition of the brakes, if the road is slippery, so it's icy or wet, if the road is in good condition, and finally the mass of the car. Now, explain how driving at a slower speed decreases the stopping distance. Well, you've got to understand what stopping distance is. Stopping distance is the sum of the thinking distance and the braking distance. Now, it's important to note that the thinking distance is decreased because as the distance travelled during the driving reaction time it is less, and the braking distance is also decreased because the distance travelled during the braking force is also decreased because you're travelling at a slower speed. The next question says, Figure 14 shows a velocity time graph for the drag car during the race. Explain the shape of the different sections of the graph in Figure 14 and use your ideas about forces in your answer. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, it's important you understand what the different parts of a velocity time graph show and how that motion links to forces. So you'll notice in section A to B, well, you can see that it's going to be accelerating because you've got a constant line going upwards. So therefore, you've got a resultant force going forwards. You'll notice at B to C, it stays at the same velocity because it's a flat line. So that tells you that it is not accelerating. So therefore, the resultant force must be zero, because the resultant force causes acceleration. Then from C to D, you'll notice in the graph here, it is going back down, so therefore the resultant force is in the opposite direction to motion, and you'll notice that it's curving, which indicates that the velocity is changing every second. So therefore, if it's decreasing in velocity every second, well, that is a deceleration. And remember, a resultant force in the opposite direction to motion causes deceleration. Now the next question says, determine the acceleration of the drag car during the first 1.4 seconds of the race and give the unit. Then determine the distance travelled by the drag car until the parachutes are opened. So pause the video now, then unpause the video when you want to go through your answer. Right, it's important to know that the acceleration is going to be the gradient of a velocity time graph. So what you do in the first 1.4 seconds, we're very lucky because it's a straight line, so we can just work out the gradient of that straight line section. So it's going to be the change in y, which is 45 minus 0, divided by the change in x, 1.4 minus 0, so it's 32, and remember the units of acceleration are meters per second squared. Now it's important to know that the distance travelled in a velocity time graph is the area under the graph. So therefore, what can we say? Well, the distance travelled during the acceleration is going to be 0.5 times by 137.5 times by 4.3, which is about 296 meters. Again, why is it a half times by those two numbers? Because you'll notice at that point of constant acceleration, it's a right angled triangle. So the area of the right angled triangle is a half base height. Now, what's the distance travelled during the constant speed? Well, it's a rectangle, so you're going to multiply the y-axis by the x-axis. 137.5 times by 2.2 is 302.5. So our total distance is the two values added together, which is 598.125 meters. Now you'll say, why have we not included this section where it is decelerating? Well, it says until the parachute is opened. So the deceleration process occurs when the parachute is opened, so you don't need to determine that distance in your calculation. Let's now have a look at some questions concerning waves. So the first question says ultrasound is a longitudinal wave. So firstly, what is meant by a longitudinal wave? And then it says figure 8 shows the ultrasound being used to measure the distance between two cars. Explain how ultrasound can be used to measure the distance between two cars. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this first question? Well, remember, when you define a longitudinal transverse waves, you've got to remember it's the oscillations of the wave and the direction of the energy transfer. So with a longitudinal wave, the oscillations or the vibrations are parallel to the direction of energy transfer. Remember, a wave is a transfer of energy and it's an oscillation. So marry those two up when you're doing your definition. Now, from this diagram, how can ultrasound be used to measure the distance between two cars? So you'll see in the picture that the ultrasound wave is being transmitted. It will then hit off the car and reflect in the other direction. You can measure the time taken for the ultrasound to go there and back, and then you can work out the distance by using the speed equals distance over time equation, because you'll know the speed, you've measured the time, you can work out the distance. But it's important to note that the distance is being measured is there and back, because the time taken is there and back. So if you were going to do this, you would either divide your distance you've calculated by a half, or divide the time that you've used in your calculation by a half, because we want to measure the distance there, not the distance there and back. The next question says, a microphone was connected to an oscilloscope. Figure 9 shows the oscilloscope trace of the sound wave detected by the microphone. Each horizontal division on the oscilloscope represents a time of 50 microseconds. Determine if the trace in figure 9 represents an ultrasound wave. So pause the video now, then unpause the video when you want to go through your answer. Right, this question involves quite a bit of work. So firstly, we notice that the time is given in 50 microseconds. So we've got to convert 50 microseconds into seconds. Now, micro means times 10 to the minus 6. So the time is 50 times 10 to the minus 6, or 5 times 10 to the minus 5. Now, you'll note here that in one wave, you'll see it's when it goes up, down, and back to the center again. So that takes up 8 different horizontal squares. Now, if one horizontal square is going to be 5 times 10 to the minus 5, well, the entire time period for the wave is 8 times 10 to the minus 5, 8 times by 5 times by 10 to the minus 5 is shown here. Then at this point we can work out our frequency by doing 1 over the time period you've calculated, and then you can see if it is going to be an ultrasound wave, because you've got to know the frequencies at which ultrasound waves take place. So you've got to be aware that a sound wave will be between 2000 Hz and 20,000 Hz. So if it's above 20,000 Hz, it's an ultrasound wave. If it's below 2000 Hz, it is in fact an infrasound wave. The next question says, stars behave like objects that emit blackbody radiation. So what is meant by the term blackbody radiation? And then stars are different colours because they have different surface temperatures. Figure 11 shows how the intensity of electromagnetic radiation emitted varies with the wavelengths for 3 stars. So compare how the intensity varies with wavelength for the 3 stars. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, it's just a definition you've got to learn. So a blackbody radiator is an object that emits all parts of the electromagnetic spectrum. Okay, so there's a range of electromagnetic radiation emitted by an object at a certain temperature. Now the next question is just looking at the information and making sure you fully describe it. So you'll see here that the blue star, you'll notice, has a maximum wavelength at approximately 400 nanometers. The white star has a maximum intensity at 620 nanometers, and the red star has a maximum intensity of 790 nanometers. So this tells you that the greater the surface temperature of the star, the shorter the wavelength at its peak intensity, and so therefore the blue star will be the brightest. Now it's important to note that for all stars, you can see here in the image that as the wavelength increases, well, the intensity increases and then decreases. But for all wavelengths, it's important to note that the blue star has the greatest intensity. You'll notice that there because it's the line above all the others, whilst the red star has the least intensity because it's the line below all the others. Now again, we need 4 marks here, so we should be making some very clear points here to ensure you've got a comprehensive answer. The next question says, the speed of the car shown on the LED is shown on an LED display. Light waves are emitted from the LED display. Light waves and microwaves are both electromagnetic waves. Give 2 of the similarities between light waves and microwaves, and give 1 difference between the properties of light waves and the properties of microwaves. So pause the video now, then unpause the video when you want to go through your answer. Right, so it's important that you can give similarities between two waves on the electromagnetic spectrum. So the most important one is that all electromagnetic waves travel at the same speed. They're all transverse waves as well, and they can all travel through a vacuum. But you can also give similarities for just any two waves. And any two waves are similar because they'll always reflect, they'll always refract, they'll always diffract, and they'll always transfer energy because a wave is a transfer of energy. Now, when you talk about differences between two electromagnetic waves, I would always link it into wavelength and frequency. So light waves have a shorter wavelength and light waves also have a higher frequency. Remember, frequency and wavelength are always inverses of each other. So when one goes up, the other goes down. Let's have a look at some questions to do with magnetism and electromagnetism. So the first question says, a step-down transformer reduces the voltage for an electrical train power line. Figure 10 shows the high voltage transmission cables, electrical power lines, and an electrical train. So the current in the electrical train power lines in figure 10 is 48 amps when the train is traveling at a constant speed. Determine the current the high voltage transmission cable provides the step-down transformer. Use information from figure 10 and assume the step-down transformer is a basic transformer that's 100% efficient. So pause the video now, then unpause the video when you want to go through your answer. Right, so how would you answer this question? Well, you'll notice that you're given what you need to work out what the current is going to be. So we're trying to work out the current in the primary. Okay, so we can say that current in the primary times by potential difference in the primary equals the current in the secondary times the potential difference in the secondary. So from the diagram we can see that the primary potential difference is 400,000 because we don't work in kilovolts, we work in volts, so it's 400 times 10 to the 3. We can see that the potential difference in the secondary, the second part of the circuit, is 25 kilovolts, so 25 times by 10 to the 3 or 25,000. And we also know from the information given in the question that the current in the second part is going to be at 48. So we've got three parts of the equation and there's only four terms, so therefore we can work out that fourth term. So we can pop in the values into the equation. We can then rearrange it to make the primary current the subject of your equation, pop it all through and you get 3 amps. Now again, you should see that makes sense because what's happened is in the secondary the potential difference has gone down from 400,000 to 25,000, so it means that the current must be going up, so the value you calculate must be less than 48. So that's a very important idea. So it's very important you can read the information in the question, sub it into the calculation and then rearrange. The next question says figure 9 shows a simple electromagnet being used to pick up some paper clips. Give one advantage of electromagnets compared to permanent magnets, and then give two changes that will cause electromagnets in figure 9 to pick up more paper clips. So pause the video now, then unpause the video when you want to go through your answer. Right, firstly you've got to know the basic properties of electromagnets and permanent magnets. Now electromagnets can be switched on and off, or you could say the strength of an electromagnet can be varied. Now secondly, you'll note that the paper clips are being picked up by the electromagnet because the paper clips are a magnetic material and the electromagnet is a magnet, so it'll be attracting and picking them up. So you've got to think how you can pick up more of them. Well, you've got to have a greater magnetic force. So how could you do that? Well, F equals BIL. So therefore you could increase the current I, or you can increase the number of turns L, so increasing the length there. So therefore what you can do is therefore pick up more of the paper clips by increasing your magnetic force. The next question says an electromagnet can be used in an emergency braking system on a train. In an emergency, a switch is closed and the moving train will come to a stop. So figure 10 shows a design for the braking system on a train. So explain why the train will stop when the switch is closed. So pause the video now, then unpause the video when you want to go through your answer. Right, when you're answering this question, again, you've just got to think, what are the properties of an electromagnet? So when you work it through, you can work out your different properties of your electromagnet. So, in this first question, what you would say is that when the switch is closed, you'll note that there's a current in the electromagnetic circuit. This will produce a magnetic field around the electromagnet, because we know that when a current flows through a conductor, it'll produce a magnetic field as an electromagnet. This makes the iron bar, which is the magnetic material, an induced magnet. So therefore, what do we know about induced magnets? Well, it'll be attracted to the electromagnet because induced magnets are always attracted. So therefore, it'll pull the brake pad onto the wheel, so friction acts between the brake pad and the wheel. So this means that there's work done against friction, so it reduces that kinetic energy. Remember, linking in step by step to make it into a logical order. Let's have a look at some questions to do with space physics. So the first question says, Mars and Mercury both orbit the Earth. Mars orbits at a greater distance from the Sun than Mercury. Give the reason why the orbital velocity of Mars is less than the orbital velocity of Mercury. Then Table 3 gives data about the orbits of Mercury and Mars. The orbital period is the time it takes a planet to make one complete orbit of the Sun. The orbital velocity of Mercury is approximately twice the orbital velocity of Mars. Explain why the orbital period of Mars is approximately 8 times the orbital period of Mercury, and you can use the equation circumference of a circle equals 2 pi r. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, you've got to understand that what does the centripetal force, the force that causes the circular motion, okay, what does it depend upon? Well, it depends upon the mass of the object, and it also depends upon the velocity of the object, but it also depends on the distance away the object is. Now, it's important to note that Mercury is a lot closer to the Sun, which is what's in gravitational attraction with, compared to Mars. So because Mars is a lot further away, well, the centripetal force will be a lot less, so therefore it will not orbit at such a high velocity. Now, the next question, you've got to think about how you can work it through. Now, you'll notice by looking at the distance from the Sun for Mercury and Mars that the distance from the Sun is approximately 4 times greater, and you can also see from the information that the circumference of Mars's orbit is about 4 times greater than Mercury's, because we can work it through by doing 2 pi r. So therefore, what we can say is the orbital velocity is approximately twice the orbital velocity of Mercury's orbit, twice that of Mars, from the information given in the question. So one goes up by a factor of 2, the other goes up by a factor of 4. Combine them together and you'll get a factor of 8 difference. The next question says, the Sun is a main sequence star. Describe the process that happens in the core of the Sun and releases energy. Why does this process need very high temperatures? And describe what will happen to the Sun after it reaches the end of its main sequence until the end of its life cycle. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, you've got to know what happens in the core of the Sun or any star which will allow it to release radiation. So you've got nuclear fusion. So what happens in nuclear fusion is 2 hydrogen nuclei will join or fuse together to form a helium nucleus. This will cause some of the mass of the original hydrogen nuclei to turn into energy, and that is what is radiated out of a star. Now, why does this need high temperatures? Well, it's important because it's 2 hydrogen nuclei. So the 2 hydrogen nuclei are both positively charged, because all nuclei are positively charged, so they'll therefore be repelling each other. So you need a high temperature to overcome this repulsion. Now, the last one is you just memorizing what the life cycle of a star is and what happens to it. So remember, there's 2 different life cycles, one for a star the size of the Sun, one for a star much bigger than the Sun. So remember what's happened to the Sun after you've hit your main sequence. Well, the star will then expand to become a red giant. The outer layers of the red giant eventually will shed and form a new nebulae. This will leave the core of the star behind as a white dwarf, and this will eventually cool until you reach a black dwarf, and it will exist like that for the rest of time. The next question says, the Earth orbits the Sun and comets also orbit the Sun. Which of the following sentences describes a difference between the orbit of a comet and the orbit of the Earth? Then explain how an object in a circular orbit is accelerating whilst moving at a constant speed. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, you've got to be aware that what's going to happen is the difference between the orbit of a comet and the orbit of the Earth. So you'll note that that the orbit of a comet is a lot more eccentric than the orbit of the Earth, because the Earth is a planet, and many planets have stable orbits around their stars. So therefore, the correct answer will be that the speed of a comet varies more in one orbit, because it's got a much more eccentric and much more irregular orbit than that of a planet. Now the next one is linking it into Newton's laws and into motion. So what happens is, as you're moving in a circle, well, then the object is constantly changing direction. Now velocity is a speed and a direction, so if the direction of the object is changing, well, therefore the velocity of the object is changing. Now acceleration is the rate of change of velocity, so if the velocity is changing, the object must be accelerating. The next question says, the Earth does not orbit the Sun in a perfect circle. The distance between the Earth and the Sun changes during the orbit. The maximum distance between the Earth and the Sun is 1.52 times 10 to the 11 meters. The minimum distance between the Earth and the Sun is 1.47 times 10 to the 11 meters. Calculate the maximum time taken for light to travel from the Sun to the Earth. Give your answer to 3 significant figures. And then the Sun is a main sequence star. When the Sun uses up most of its fuel, it will expand as far as the Earth. What type of star will the Sun be at this stage of its life cycle? So pause the video now, then unpause the video when you want to go through your answer. Right, so how would you answer this question? Well, we know that speed equals distance over time, and we need to work out time. We've got speed and we've got distance. But the important thing to note is, what distance do we use? Well, we're trying to work out the maximum time. So the maximum time will occur with the maximum distance, because if you've got a further distance to travel, well, therefore it's going to take a longer time. So you substitute in the values, ensuring the maximum distance into your equation. So we say 3 times 10 to the 8 equals 1.52 times 10 to the 11 over the time. Rearrange it to make time the subject, so 1.52 times 10 to the 11 over 3 times 10 to the 8, which is 506.666 recurring. Now we need to give our answer to 3 significant figures, so we start counting at the first non-zero, which is 5, so 506, there's 3 significant figures. We then check the fourth one to see if we need to round, and we do, because the number's above 5, it's 5 or above, so therefore it's 507 seconds. Now the next one is just a fact you've got to learn. After the main sequence, a star will become a red giant. Now the next question says, a different star in our galaxy is 30 times bigger than the Sun. Explain what will happen to this star after leaving the main sequence until the end of its life. So pause the video now, then unpause the video when you want to go through your answer. Right, again, like I said before, you've got to memorize the life cycle of a star when it's either a star that's similar size to the Sun, or also a star much bigger than that of the Sun. So you've just got to memorize what happens after the main sequence process. So stars much bigger than the Sun will swell not to become a red giant, but a red supergiant. Now in this process, helium will fuse into the heavier elements such as carbon, nitrogen, oxygen, and get all the way to iron. Now as it expands as a red giant, it will cool. Now eventually the outer layers, once you reach iron fusion, will be blasted away in a supernova. Now in a supernova, that's the only time an element heavier than iron will form. Okay, and then ultimately after the supernova, you get a new nebulae, but the core will collapse into either a neutron star, a star made of just neutrons, or if it's a very large star, a black hole. So that brings an end to our revision session on today's lesson. So if we've been successful, we should be able to answer GCSE Physics examination style questions, assess our understanding on GCSE Physics, and understand what topics we need to improve upon for GCSE Physics. So thank you very much for watching this revision session on Paper 2 for GCSE Separate Science Physics. Thank you very much and have a lovely day.